this video, we will cover a few common analytical use cases that can be performed using geospatial functions. The first one we will look at is filtering data. Filtering is a very common analytical operation that is used to identify records in a table that meet a particular criteria. In the case of geospatial data, these criteria can be a spatial attribute or a spatial relationship. Let's first look at an example that uses a spatial attribute. Say we have a data set with all the states in a particular country. We would like to filter and keep all those states that have an area greater than a particular threshold. We can use the spatial attribute function st_area to compute this area and then use that to identify all the states in the data that have an area greater than that threshold. Now let's look at a case that uses a spatial relationship. Let's say we have a database with cell phone locations and we want to identify all the phones that are say 1000 meters from a particular cell tower. We can do that using the st_dwithin function, where d stands for distance, to filter all the cell phones that are within 1000 meters from the tower. Next, let's check out spatial joins. Joins involve combining two different tables based on some criteria. In geospatial analysis, this typically involves the use of a spatial relationship between the geometries. For instance, let's say that the table to the left has county-level geographic boundaries and demographic information for the state of New York in the United States. And the one to the right has information on the locations and characteristics of all the hospitals in the US. Now say we want to identify the access to healthcare resources at the level of counties in New York. We can do that using a spatial join that identifies all the hospitals that are spatially contained within each of the county boundaries. Now we have a single table that contains all the information that we need to understand access to healthcare resources within counties in New York State. Summarizing is a way to calculate aggregate statistics about the data. This is usually performed by grouping the data along a particular categorical variable before computing a summary attribute within each group. For instance, say we have a table with a geometry column that contains the borders of states and the roads in them. A plausible analytical task for this type of data would be to calculate the total length of roads for each state in the table. We can do this by grouping the data by states and computing the total length of roads within each group using, say, an attribute function like st_length. Another aggregation technique that is particularly relevant for large data sets that Kinetica deals with is called binning. Binning involves aggregation of data into spatial buckets so that we can visually see the summary statistics for the data. For instance, let's say we have a large data set with a location and type of traffic incidents across the US. The plot of this data might look something like this. At first glance, it is hard to observe any meaningful trends from just looking at the most granular level of data. However, we could use the bounds of this data to create a new spatial hex grid layer using the st_hex grid function. This grid can then be spatially joined with this data. This allows us to group traffic incidents based on the bins to calculate summary statistics that can allow us to draw more meaning from the data visually than simply looking at the most granular level of data. This brings us to the end of this video. In this video, we covered how to combine and apply three types of functions that compute attributes, identify spatial relationships, and construct new geometries to filter, join, and summarize spatial data. There is one more area that we haven't explored here, which is the analysis of tracked data. We will cover this in a different video.